Okay, for today's lesson, we're going to work on factoring by grouping, which is kind of a different technique than we've used before, but let's look at the logic of that. We'll look at a situation like this. Now, we have four terms here. Generally, when we have four terms, we're going to start to look for other ways than before. With trinomials, we just went like this and figured out what they were. We can't do that here because this is kind of a mess with the four terms. So what we're going to do is we're going to do what's called factor by grouping. Because I look at this and say, is there a common factor in all of these? And there is not. This is no coefficient other than 1, and there's no variables here. So immediately I can say there's no common factors. So what I'm going to do is I'm going to break it up into two different polynomials. First, I'm going to look at just this part right here and say, what's a common factor in these? And I look at that and I say, well, this is x squared and this is x, so there's a common factor of x squared. And then what's left in here would be x plus 4. And I check that. X squared times x is x to the third. X squared times 4 is 4x squared. So that part's fine. Then I'm going to look at this part over here and say, what's a common factor here? And that's going to be 3 positive, so I'm going to say plus 3, parentheses. If I take out a 3, I'm going to have x plus 4. And I look at this and say, this looks kind of peculiar. I have x plus 4 and x plus 4. And what I want to do is kind of compare that to a different problem. Suppose I had a problem that looked like this. I don't know, what am I going to say? X squared y plus 3y. Suppose it has something like this. I'll say, what's a common factor here? You'd say, well, y is a common factor, so y comes out, and what's left is x squared plus 3. Now, this problem over here is really similar, and then I do have a common factor. There's two large terms, this term here and this term here. Now, if you think about it, and this is where better math students start to separate themselves, is they realize that x plus 4 is just a number, similar to y being a number. So basically the common factor here is x plus 4. And then what's left is x squared plus 3. So this would be the solution, or the answer to this being factored. If I did FOIL for this, I'll get x squared times x, which is x to the third. I'm going to get x times 3. That's going to be plus 3x. 4 times x squared plus 4x squared. And 4 times 3 is plus 12. And if I switch the order so that the higher power of x's are in descending order, x cubed plus 4x squared plus 3x plus 12 is exactly what I started with. Okay, so that's simpler. Break it up into two different polynomials and factor out, then look for common factors at that point. Let's do a couple of more. This one here, I'll do the same thing. I'll break it up into this and this. So the first thing I'm going to take out here is 2x squared, parentheses, and then this is going to be x minus 3. Because check this out, 2x squared times x is 2x to the third. 2x squared times negative 3 is minus 6x squared. That works. Here I'm going to take out a 5, so plus 5 parentheses x minus 3, and that works. X minus 3 is a factor of both of these. So now that becomes x minus 3 times 2x squared plus 5. Now if you wrote it this way, 2x squared plus 5 times x minus 3, it's the same thing. So that's your solution to that one. The last one is a little bit trickier, and we have x's and y's and a whole mess of stuff. Let's just see what we have here. We'll first do this term right here, and then we'll do this one here. And there's a little trick with this one we have to work on. For this one, we're going to say that's common terms would be 5x. 5x parentheses. What's left here is going to be x squared minus y squared. And that looks great. Now over here we got a little bit of an issue here, because if I take out look at common 2y, so I can say if I said plus 2y, this is what would happen. I'd have plus 2y, and then I'd be left with x squared, negative x squared plus y squared. And that gets to be a little bit tricky because these don't look the same. X squared minus y squared, negative x squared plus y squared, they're actually opposites each other. So I'm going to say, well, wait a minute, what if I, instead of taking out a 2y, let's back this up and say 5x times x squared minus y squared. Instead of that, I'm going to take out a negative 2y. And at that point, this won't be, I won't be taking this out anymore. It will look like this. It would be, I take out a negative 2y, that's going to leave me with the negative 2 and the y out, which leaves me with x squared. Now I take out a negative 2, this was positive, which means it has to be negative y squared. And I can always check, does that work? Negative 2y times x squared is negative 2x squared y. Negative times a negative is positive 2y to the third. And now I notice that I have common factor of the x squared minus y squared. So I would write x squared minus y squared, parentheses, and then I have 5x minus 2y. And before I start to say, great, I figured the problem out, I have to look at this and say, can I factor any of these anymore? And there should be bells going off in your head right here because that's the difference of squares. So that would be x plus y times x minus y. We should be good at that by now, times 5x minus 2y. So this would be the answer we're looking for this problem. That's the factored form of all this right here. And we're going to have to do a lot of factoring in the next couple of weeks to simplify expressions and solving stuff. Okay, that's about it. Hopefully completing the square, it's a little bit easier once you start to do that.